for Mackenzie and for Romeo, I think. This is section 9-2. This is only the first half. We're going to only go up to example 3, which is the top of the second page. But here's how this works. We're doing angles and angle measure. So give me your full and undivided attention for the next 10, 15 minutes, and we'll be done. There are two different ways of measuring angles, and they are first in degrees, which I'm sure you have heard before. Degrees. And then there's something called a radian, which kind of sounds like radius.
Or radio.
Or radii. Radius. Okay? Degrees and radians. Okay? And this is kind of similar to like inches versus centimeters, right? Like converting. They both are measuring the same thing, like measuring length or measuring angles, but just two different units of measure. Okay? And we'll talk more about radians later on. But just for today, we're going to be dealing with degrees, okay? Now, you guys have done, like in elementary school and junior high, all this stuff, angle measures. And normally your angle measures are like 0 to 180 degrees, right? Like that's what you've been used to, okay? We're going to be dealing with angles that are like 200 degrees. We're going to be dealing with angles that are like 450 degrees. We're going to be dealing with angles that are negative 70 degrees, right? And I'm going to explain to you what all of that information means. So don't just think angles are less than 180 degrees, right? We're going to have some angles that are really large, some angles that are negative angles, and we'll explain to you all what that means, okay? But for the first thing, I want you to look at this diagram, and this is a diagram in what's called standard position. Standard position, okay? And I'm going to P-O-S-I-T-I-O-N. I can't spell. Standard position starts with your first side of your angle on the positive x-axis always. That line will always be there. They've kind of drawn like a coordinate plane where you have like an x and y axis here, and your first side of your angle will always be this line right there, always in standard position, okay? Then your angle rotates counterclockwise. Counterclockwise, okay? And it rotates counterclockwise, and one of the ways that I think about this and like how that it rotates, you guys remember in elementary school when you would do like quadrants? Yeah. Or I guess we've done it probably in this class before. Which one's the first quadrant? 1, 2, 3, 4. Have you ever kind of like wondered why they're numbered that way? Like, why wouldn't they do like 1, 2, 3, 4? That would make more sense. Left to right, right? The reason why they number them 1, 2, 3, 4 in that way is because that's the way that an angle rotates. So now you know. Now it's coming full circle, and this is why we've been doing this stuff all along, okay? So 1, 2, 3, 4. Angles in standard position start there at 0. If I go like this far, that's about a 45-degree angle, right? If I rotate this far, that's a 90-degree angle. It's like a right angle, right? If I keep going around, and let's say I stop here and make it go straight across so that they're opposite from each other, that's 180 degrees. Did you know that? Okay? One full circle is how many? 360. So going all the way around is 360 degrees. Okay? Now you have to do a little bit of math, but from here and 3/4 of a circle is about 270 degrees. Like look at the thing, right? 270 degrees, etc., right? So what we're going to be doing is we're going to be mapping angles onto these coordinate planes and rotating them around. So you can graph a 200-degree angle. You can graph a 450-degree angle, that type of thing, okay? It's just starting in standard position and rotating around counterclockwise. So let's do an example, and let's go down to this one, which is 215 degrees, okay? So we always start with our first part of our angle in that quadrant, so put it there, okay? And I know that if I rotate from here to here, that's 90 degrees, right? If I go one more, that's 180 degrees. If I go one more, that's 270 degrees. That's too far, right? I want to go 215 degrees. 215 degrees. Now, it's going to be somewhere in that third quadrant, but is it going to be like half? Is it going to be less than half? Is it going to be more than half?
Less than half.
Less than half. How do you know that?
Because
you're right.
How
many degrees is like half? Is like this right here. 45, okay? How many degrees is it past the 180? If I would subtract 180, this is 35 degrees, right? So it's only 35 degrees past 180, so it's less than half, right? So I'm going to draw this a little bit smaller, and I'm going to go like maybe there. That's less than half, right? Halfway between would be 45. I'm not going to be too particular about that as long as you put it in the correct quadrant. That's fine. But this is a 215-degree angle. Make sense? Yes?
Wait, so we're like the 400 degrees.
Oh, we're going to talk about that. Okay, so let's go to B. B is a negative 40 degrees. Okay? Negative 40 degrees. We're still going to start in standard position this direction, but we're going to go clockwise. So if I go clockwise 40 degrees, we're in quadrant 4. Are we halfway, less than halfway, more than halfway?
A little before halfway.
A little less than halfway. So like there. This would be a negative 40 degrees because we're going clockwise, right? Clockwise instead of counterclockwise. Negative angles go down first. Okay. I love that. Yes, that's very, very good. Very, very good. Okay. All right, good. Negative angles are clockwise. Yes? Okay, let's go down to this one, which is going to be an angle that's bigger than 360 degrees. So here it is, Isaac. This is wakeboarding, and it's a combination of surfing, skateboarding, snowboarding, and water skiing. Whatever. One maneuver involves a 540-degree rotation in the air. Okay? If I'm standing facing you, or if I'm driving my car and I hit ice and I flip completely around and I'm still facing the same direction after I've turned around, I've done 360, right? This is more than that, okay? So we're doing 540 degrees. So we still start with our angle in standard position right there. We're going to graph this angle, okay? So if I go around, we're going to make like a cinnamon roll to show that like we've gone one full circle around. So there's 360 degrees. Yeah?
Oh, then you
Okay?
just put it
Now, we want to go 540 degrees. If I've already gone 360, how many more do I need to go?
180.
I subtract 360, you said 180? Okay? So now I'm still back at this spot. I want to go 180 degrees more than that, right?
No, you just do a line across.
So I'm going to go there, and this direction is where I'm going to end up, okay? So
This is so easy.
this is me. I'm going to go 540 degrees. You ready? And I'm hoping I don't fall over, right? This is me facing forward. Here's 360. Where am I going to end up if I go another 180?
Backwards.
That's 540 degrees. So I've flipped and I've gone facing the direction that I came. Make sense? Yeah? Good? So that is a 540 degree angle. To represent that it is more than one full circle, you need to do the little cinnamon roll thing. So we can show that it's around more than one cycle. Yeah? So do this little cinnamon rolly thing in the middle, okay? So we can see that. Happy with that? Yeah? Okay, let's go down and let's do one more thing. One more thing. Ready for this? I'm going to start with like, let's say a 20-degree angle, okay? And let's map him. 20 degrees is just going to be in the first quadrant, a very, very small angle, like here, right? 20 degrees, okay? Now this 20-degree angle, let's say instead of going this direction, 20 degrees, I want to go around and go the long way to get to that mark. I would have to go 340 degrees this direction to get to that point. Now, since I'm going this direction, it will be negative 340, okay? So negative 340 degrees, we are saying, lands me in exactly the same spot as 20 degrees does. Does this make sense? These two things are called well, it's right here. I won't write it. They're called coterminal angles, okay? Let's break apart the word coterminal. Co means same. Terminal means stop. So they are stopping at the same place. Co-terminal. Stopping at the same spot. Now, let's do this really quick. Technically, there are an infinite number of coterminal angles. So rather than doing 20 degrees this direction, let's say I go around and I go past it and then I go and land there. How many degrees have I gone? 380 degrees, right? That's like adding 360 degrees. So I can start with 20 degrees and I can add 360. That's just going around one more full cycle, right? And that's 380 degrees. Or I could start with 20 degrees and I could subtract 360. That's going one less circle around. That's negative 340. Okay? Or I could keep going. I could start with my 380 and add 360. That's 740 degrees. I could add another 360. That is 1100. 1100 degrees, yeah? 1100 and 740 and 380 and 20 and negative 340 are all called coterminal angles. I could start with negative 340 and subtract another 360, which is negative 700 degrees. I could subtract another 360 and it could be a negative 1060 degrees, right? These are all more coterminal angles. So I could keep going and going and going and going and doing more flips on my skateboard. Heaven forbid I'm going to get dizzy and fall over, right? But the more flips you do, you're just adding another 360 or subtracting 360, and that's another coterminal angle. It's going to land you or terminate in the same spot. Does that make sense? Coterminal, same terminating spot, same stopping place, right? Make sense? Yeah. So adding 360, subtracting 360. So let's go to this back side, and let's do part A. On example 3, this is the last example, except I'm going to add a part C onto here, and let's talk about 400 degrees. So add on part C, we're going to do a 400 degree angle, because there's a little bit of a trick to that one, okay? So starting with A, we want one positive, underline the word positive, and one negative angle that is coterminal or stops at the same place that 130 degrees stops. What quadrant is 130 in? The second one. It's like there, right? That's 130 degrees. So if I want to go this direction, instead, I can subtract 360. And how many degrees would that be? 230. Negative 230 will be the same spot as positive 130. Does that make sense? Negative 230 is coterminal with 130. Okay, now, if that's a negative, this is my negative angle, right? If I want a positive one, how do I find the positive angle that's coterminal with 130? Let's add 360. So start back at 130 and add 360. 490 degrees is a positive angle that is coterminal with 130 degrees. So I have my negative one, I have my positive one, I have my original one. Good? Okay?
No.
You need a positive and a negative every time.
Hang on.
Okay?
What was it? Negative 230.
Yep, negative 230 and 490. You're just adding and subtracting 360. Okay? All right, negative 200. If we start with negative 200, I want a negative angle, so I'm going to go back around the other direction. Let's subtract another 360. My negative angle will be negative 560 degrees. Okay, that is coterminal with negative 200. They're going to stop at the same place, just one less cycle around or one more cycle around. Okay, how do I find my positive one? Negative 200 plus 360, which is 160. 160 degrees is a positive one. So I have a negative one here and a positive one here. Okay, good? Happy with that?
Skip section.
Okay, then C, I added on here, add on 400 degrees. I want to know a positive and a negative coterminal angle with 400 degrees. So I'm going to do the same thing as what I did just a second ago. I'm going to subtract. Do I subtract? Add. Let's add 360. And I get 760 degrees. Yeah? And I take 400 and I subtract 360. And I get 40. But the problem is, where's my negative angle? I don't have one yet. Because 400 is larger than 360 to begin with, I have to subtract another 360, which is negative 320 degrees. Does that make sense?
Yes. But
Okay.
you could also just add 40.
What do you mean?
One of them would be 40 and then you have to have 760.
Right. So Riley said I wouldn't even have to have 760 if I just did the 40 and the negative 320. That's a positive and a negative one right there. We don't even have to do the 720. So or 760. So if you have an angle that to begin with is larger than 360 or negative 360, you can just add 360 twice or subtract 360 twice to get your positive and your negative. It's not that you have to add and subtract 360 each time, right? Does that make sense? Am I clear as mud? Okay.
Yeah.
About. You're just doing one more full cycle around. It's just like flipping your car around one more time in the snow. Like,
So if I
Donuts.
have,
whatever.
Donuts.
why would I need to take two 360s to add them on?
Subtract them on, you mean?
You
Or
said-
when would you have to add them on? If it was like negative 400 degrees, you would add 360 to get negative 40 degrees. So that's my negative one. But then I would have to add 360 on again to get my positive 320 degrees.
Okay.
So you might have to add 360 twice, subtract 360 twice, or do one of each to get your positive and negative. Make
Okay.
sense? Yeah. Very nice. Good?
Yeah.
Happy with that?
For the home.
Yeah, for the homework. Here we go. So on the homework, I'm giving you a lot, but these go by really fast because the first ones you're just mapping. So do 1 through 10 on the homework on the skills practice side. 1 through 10 because that's all you know how to do yet. And then do 1 through 9 on the other side.
So 1 through 10. On
1
the
through
front.
10 and 1 through 9. Those sections, okay? Very good. Questions? No? All right, get a start.
I guess throw something in.
No, you can't, Carson. No.
Shut. Shut your lazy mouth.
All right, goodbye, whoever this for. Romeo and Mackenzie.